Hello everyone, here is our lesson number 6. So we are now entering the exercise 5 of your book, and that is the hyperbola. Alright, so you already know that an hyperbola is created by an equation that has a division by x. And you will find the q value and the p value that's going to shift your graph. So this should be already known now. Alright, so now let's enter the specificities of hyperbola. So here, at the beginning you've got a summary of what we already saw, and here we enter the specificities. So, an hyperbola is made of two arms. So, in the other graph that we saw, it was only one line, a continuous line, but for hyperbola, you've got two arms. You've got one left part, a jump, and a right part. So this jump is made because of that division by x, and that will create an undefined value when the denominator is equal to 0. So this creates two separated sets of data, your left arm and your right arm, with the center being that undefined x value. Alright, so you can see that this line and that line are splitting your two arms, and those two specific straight lines separating the two arms are called asymptotes. Alright, an asymptote is a line that will be reached by the graph on an infinity point. So if you carry on that graph in the positive infinity x value, this graph will at some infinite point reach the x-axis. It's the same here. If you get extremely close to 0, this line is going to reach the y-axis. But that's on an infinite point, which is technically not reachable. Alright, so the asymptotes are lines that are very close to your graph, but that's never going to be reached. And an hyperbola has two asymptotes, an horizontal one, that's for this is here, and a vertical one, that for this graph is here. Alright, the good news is, if you can read easily the p and the q value of your equation, the two asymptotes have for equations y equals q and x equals p. Remember we said the q value applies on the y and the p value applies on the x. So that's the same here. Let's check the two asymptotes of this first one. A basic hyperbola, y equals 1 over x. For this one, the p value is 0. There is nothing after the x here, and the q value is 0. There is nothing after the fraction here. So that means if the horizontal asymptote as y equals q, then we have the first asymptote as y equals 0. And y equals 0, and that corresponds exactly to the x-axis. So our first asymptote is y equals 0, and that's here the x-axis. Now, the vertical asymptote is equal to x equals p. So x is equal to 0 here. And x equals 0, it's a vertical line. We have the x equals 0 and the y equals 0. Those two lines are the two asymptotes, and they split our hyperbola in the left arm and the right arm. Alright. This x equals 0 is asymptote because if 1 is divided by 0, we get an undefined value. Technically we get infinity, and for x equals 0 the graph is going to be up to infinity. Alright, so that's the two asymptotes. Now, same thing again, if we have in the equation a p and a q value, it's the same rule, but it's just shifted right, left, and up, down. Alright, so if we take, for instance, this one, y equals 1 over x minus 1 plus 2. Here, we have the p value equals 1, here, and we have the q value equals 2 there. So p is 1 and q is 2. Alright, the graph is shifted 1 unit to the right and 2 units up. Well, that's exactly what we have. The two asymptotes are shifted. The horizontal asymptote here is y equals 2. Here, this horizontal asymptote is y equals 2. And it splits our right and left arm of the hyperbola. For the vertical asymptote, it's x equals p. So x equals p, that's x equal 1. For x equals 1, we have a vertical straight line, and that is our asymptote here, splitting right and left arm of our hyperbola. To make it easy, when you take your table at the beginning when you want to draw, sketch your graph, you're going to think first, where is your p value? Because your p value is going to be the midpoint, splitting right and left. So, when they ask you to sketch an hyperbola, you must be careful. Alright? So you select your x's. The first one that you're going to select is your x equals to your p. So for this one, 1 over x minus 1 plus 2, our p value is 1. So in the center of my table, I'm going to use x equals 1. But if I use x equals to 1, I'm going to have a division by 0 because my denominator is 1 minus 1, 0. So that makes that equation impossible, undefined. That is why inside for the y value, I'm going to draw two straight lines, like two parallel lines here. This is the symbol for asymptote. So for x equals 1, the y value is the asymptote. And that's the center. So now, because I want to draw the two halves, the two arms, I'm going to choose 3 values greater than my asymptote. So if x was 1 for asymptote, I'm going to choose 2, 3, 4, for instance. That's going to help me drawing my right arm. And on the left, I'm going to choose 3 values smaller than the p value. For instance, 0, minus 1, minus 2. That will help me drawing the left arm of that hyperbola. Alright. So here, I didn't fill the value for you because I just want you to understand the method. But you can calculate. If x is minus 2, you substitute minus 2 here. Calculate the function. Give the y for the 6. And then you can check and verify that you would obtain this graph. Here, the right arm greater than 1 for x greater than 1. And here the left arm for x smaller than 1. The two asymptotes, the center, the vertical one is x equals 1, and the horizontal asymptote, the p value, which is 2. Alright. So just here, when you have a hyperbola, you must just be careful. What is your p value? And you take 3 values smaller, 3 values greater, to build a nice table that's going to help you to draw, to sketch your graph nicely. It's fine if you miss a few values. If you realize later that you only have half, then you can still add in your table and make sure that you've got both arms. Alright, then here we don't forget what we did already previously. Don't forget that you know now how to calculate the x-intercept and the y-intercept. So I rewrote it here for calculating x-intercept. You change the y equals to 0 and you solve. So you take your equation equal to 0, you solve for x, and you give the coordinates of the x-intercept where it crosses the x-axis. Same for the y-intercept. This time the x is 0. So you take your equation, substitute the x with a 0, calculate the value of the y, and that y-intercept as for coordinates 0, 1. Here it crosses the y-axis at the point 0 for x, 1 for y. Alright. So that's all for hyperbola. What you must remember: two asymptotes, y equals q and x equals p. If you know that, you know that will be your center, 3 smaller x's, 3 greater x's, and you check and draw your hyperbola nicely. Alright, so to make sure that you can do this and that you understand it, you will just practice with 3 questions that comes out of your book. So look at the question 5.1, 5.2 and 5.3 in your unit 11, and that is for Wednesday. Alright, enjoy, bye bye.